Hey everyone, today we will be recording a new series of our machine learning system design, a new part. Actually, we will be doing two of those. The tricky part is that one of those is related to features and another one is bias variance. Another thing that I'll change is that I will try to stream all this from my iPad. Okay. Yep, I'm just checking that it works and that the whole system works well overall. Yeah, looks like it's working. Maybe the quality is not the best one. Sorry about that. But let's continue. So I will be sharing two videos today, hopefully. If this one doesn't take too long, I will then start streaming the next part, which is bias and variance, which is a more interesting one and where I'm especially proud of how I showed everything there. But first we need to finish discussing features. Last time we were discussing high cardinality features. Sorry. And now we have two simple topics left, which is leakage and coverage. Okay, let me check how this works now. Is it better? Yeah, the quality is better now. And I need to open it on my phone just so that I can check how the whole thing works. Okay. This is strange. Features, leakage and coverage. Okay, live. Great. This seems to be working now. Let me start the operation of where I try to share iPad screen. So I need to share entire screen first. Now you will see this thing, and then I need to start sharing screen like this. And then I need to check whether this is working. Okay. Okay, it's working. And you were waiting just because there is a lag between the time that I'm sharing things and the stream itself. But okay, so we will be discussing leakage and we will be discussing coverage. We will obviously start with leakage. And I have just shared a few examples here of what leakage can mean. We already touched upon leakage in our first part where we were talking about evaluation. So the way to consider, the reason to consider whether you might have leakage is when your offline metrics are much better than online metrics first, and second, when you are achieving surprisingly good results in your offline metrics. So let me give you a few examples where it's kind of obvious, but maybe not very obvious that you would have leakage. So first of all, let's say that you have, you're predicting things about the loan, and you will predict whether it will default within 90 days. And the problem is that, let's say you take this feature that is like days since last payment, which is a very reasonable feature to have. The problem is that this is part of the definition of defaulting on the loan. So if you are not paying for several months, let's say that's the definition of defaulting. So if you have already not paid for like 1 month, you are already partly have defaulted. So if you just see that all loans that had 90 plus days, let's say, since last payment, all of those loans are considered defaulting, then you can use this feature, but that will tell you nothing about whether the loan will default or not. Another thing is predict whether a user is abusive, right? So this second example here. The problem is, how do we define an abusive user? So we can use this feature, that number of reports that this user received. But again, there can be circular logic for if the user has received a report, then probably they had at least questionable behavior, and they're definitely closer to being abusive. But if they have already received a few reports, and after all those reports they were considered abusive, like there was a process and we decided that this user is abusive, then obviously this directly correlates with the target and it impacts the target. And the problem is that we don't know what will happen in the future. And we don't know, I will talk about this later. Everything depends on when we are trying to make a prediction. It will become clearer in a moment. So then let's say we also want to predict whether a support ticket will escalate. So if we know that agent is assigned, that basically means that the ticket is especially hard and it's already kind of escalating. So again, we need to understand how this feature works in the context of making predictions. So, for example, let's say that we have a timeline here, right? And on this timeline, we are making predictions. And we can make predictions at different points of time. So let's say here we are making the prediction about whether the loan will default. And we know that here was the last payment date. So by this prediction, we didn't have any like significant amount of days since last payment. So assumingly like that's when the user finally paid and have stopped paying afterwards. So if here we use this data about like when the user has stopped paying, is it still valuable to predict whether the user will default or not? Probably yes. So the thing is, we are looking into the future a little bit, right? Or like we are looking into the past, but it depends on what we want to do. So if we want to predict what will happen to this loan in 90 days from now, like from whichever prediction we have, then it's reasonable to have predictions that use these features like date since last payment. Because maybe if we make this prediction here, we will be much more certain that the loan will default, but still not 100% certain. So the only thing that matters is that if you want to predict something that will happen 90 days after your prediction, you can never use in training data from that happened in 90 days before the actual target was resolved. So if on, let's say, 1st of April, you have figured out that this particular loan has defaulted, then to make a good model, you cannot use any data that happened in 3 months, in 90 days before this 1st of April date. So if in training you're using all of those features, but you're not looking into the future, you are still training a good model. It's just then the question becomes like, do you even need those features? If you never get days since last payment as bigger than 30, does it matter? If you have like 0 reports, does this feature matter? Maybe we have abusive users that previously had reports but weren't considered abusive, and then it will be a good feature to use. So again, just to summarize this thing about leakage. Leakage happens if, when training the model, you're looking into the future. So again, train, test, split, and theoretically, if you have like here, for example, 90 days, if you have this range between the last event and the target, then you cannot use any data from in your training data that happened between this last event and the target in those 90 days, for example. If you don't use that, then it's fine. You won't have leakage. But you might also not get any value from those features. Okay, we have covered leakage. Let's now cover coverage. Coverage is called the silent killer. And why is that, right? So let's assume like whatever the model we have built, let's say that it has a reasonably big amount of coverage for the feature. So what is the coverage for the feature? It's a ratio, a share of the whole data set where this feature is has a meaningful value. So like non-zero, not a number value, a value that is actually coming from the data set from a good source. So we can consider like the ballpark estimate is that if feature has lower than 70% coverage, then it's questionable. If it's lower than 30, it's very questionable. So we should aim obviously for like 100% of coverage. We will also discuss that it's not always possible. And one reason why it might not always be possible is ads. Let's say that in ads, you have a combination of features. Remember, right? Last time we discussed high cardinality features. Let's say we want someone who is both an iPhone user and lives in New York and is in a specific age bracket and maybe went to a specific university. So all of those things, you are starting to limit your amount of people considered for this particular bucket more and more. So if you are, I wanted to say that you're decreasing coverage, but according to our definition, we are not really decreasing coverage. We are just making a variable that is 1 in very, very small percent of the time, and then 0 in all the other percent of the time. So that's not a good example here for the coverage, but maybe let's give a different example. We have a survey that we are giving to our user, to our bank clients, and they're filling this survey with like how satisfied are our clients with our bank's services, right? And then obviously a very, very small percentage of users fills this survey, but let's say 5%, so it has very low coverage. Should you use that for default predictions? Well, if you find that users who have very, very low scores for our bank have higher chance of defaulting on the loans, then yes, this is a good feature. Yes, you will be only making good predictions for those like 5% of people, and for everyone else, you will have to figure other ways to predict these things, but it's still very informative and you still have to use that. Okay, now let's discuss this thing. One of the important things that you can add in some cases is not just that the value is missing, but also that the value, like the fact that the value is missing is a variable itself. So you can create a one hot encoded parameter where the value is either missing, like is the value missing or not, 1 or 0. Why is this important? Yeah, an obvious example is given here, right? Where the user hasn't filled the profile. So if the user hasn't filled their profile, it means that they're less engaged, less motivated, probably they will behave differently on our platform. So this is a good feature to have at all. And that also means that we can, for example, XG boosting famously can work with missing values. It assigns a specific value to the missing values, and for tree-based models, it works well. So it automatically processes missing values in this regard. But in some other cases, you might need to add a specific value there. And finally, what's written here, what's shown here, and why do we call coverage silent killer? The problem is, let's say we are predicting ETA for delivery, right? And let's say we don't even have like 70%. Let's say we have 100% of the time. We have some very informative features. Let's assume weather forecast or current weather. And then at one particular moment, you see that, or you don't see, but what happens is that we are getting this weather forecast from a third-party API. So there is a company which provides us with this information, and their API breaks down, it stops working. So what happens to us then? The coverage of this feature of the current weather drops significantly, basically from 100% to zero in this scenario, which is a drastic change. And our model starts relying on the data where it doesn't have information about the weather. But what if, as is in the case of predicting the time for delivery, what if we have what if this feature is very important? Then in our models, it got big weights, and we probably are not working well with it when it's missing. We might not even have had situations when it was missing in our training data. So we have data drift, and our model quality will very, very fastly deteriorate. And if we are not tracking this coverage, we won't see that. If we have created a model that still works, which is probably better than the model that is breaking when this value is missing, and we continue making those predictions, if we don't track this coverage, then our model will start failing silently, and we will not even know anything about it. So that's why it's called silent killer. And finally, some of the tips on how we need to treat coverage. So first of all, if we also need to check coverage by slice. So for example, there can be some subgroup of our data set where for this specific slice, we stop getting the data. And on average, it won't be significant, but it will be very significant for this specific subset of samples. In this regard, we need to not only track our coverage, but we also need to track it by different slices. And as I have said, right, like it can create training serving skew. For example, when we are depending on the external service. Another example would be not that the service starts failing altogether, right, where we go from 100 to 0%. What if the load increases and some of our requests start timing out? Like what if 95% of requests are fine, but the last 5% of the requests are timing out and we are not getting this data? Then we are getting training serving skew, where in serving, we are missing some data, and because of that, we cannot make good predictions. And finally, like cardinality check, it's not related to coverage directly. It's more for like those features that are very, very imbalanced, where we have for relatively big cardinality features, where we are creating this other category. If it starts growing such that we are putting most of our data set in other category, then probably our model is underperforming, or probably our feature engineering was wrong, or basically we need to track this and understand what's going on and what to do about this. Okay, and this brings me to the end of this specific part of my presentation of features. So I will now check if there is any question. There are any questions? No, there are no questions. So now I will stop this stream after 20 minutes, and I will start another one where I will be discussing bias and variance. See you there.